welcome to the Bytecode. I'm your host Shafu, and today's episode is with Mario, who wrote soldeer, which is a package manager for Foundry. Mario, thanks for taking the time, man.
Oh, hello. Thank you for having me, and thank you for letting me present the project I've been working on for the last, I think, 6 months in my free time. So, what is Soldier? Well, I'm a security researcher, and I've been in this field for some time. So, once kind of like the field has moved to Foundry, the constant issue that we had was actually how do we manage the dependencies? And I've been battling with Git's support just for a while, and I feel like, okay, every time I was going and trying to audit a new or like look on a new code, I had to say, okay, what type of dependency this project is using, and it was like a nightmare. So in an afternoon, I thought that, well, why don't I do something about this? No. So I started to create this very lightweight dependency manager for Solidity, and uh, I had to choose Rust as well because Rust is very popular in our crypto world, and I started to build it. What Soldier basically does is pretty simple. It's a CLI tool that helps you manage dependencies. It has a central repository, especially like something like npm.js or like creates as well. And it lets you manage dependencies very lightweight and very easy for your Solidity project. It currently it's at version 0.2.18, and I've been working on it for the past 6 months. And I'm gonna go through it for the new members who do not know what exactly this does. I started this as a standalone CLI, but after some discussions with the founder team, we managed to actually integrate this into Foundry, and now the Soldier is used as an alternative package manager. Um, uh, in case you don't want to use the default GitHub modules, we plan to make this the default option at some point, but we need first more. Uh, we need a bit more feedback from the community and making sure that we take the right decisions on what exactly a dependency means in Solidity and so on and so forth. So Soldier has some simple commands, I'm gonna go right into them. Let me skip the installation. So by the way, everything I say here regarding Soldier install and so on and so forth is the same in Foundry. The only difference is that it has in front of it Forge. So it actually Forge Soldier install and so on and so forth. But I'm gonna just refer to them to keep the naming very short. I'm just gonna refer to them as Soldier and not Forge Soldier and so on and so forth. So Soldier install, it's the simple command that lets you install a dependency. What this does is basically accessing the central repository and retrieves a version from there. You can also install a dependency from a specific URL. For example, if you have like a zip that it's located on your send your own website, or like you have like your own I don't know, Amazon S3 bucket and so on and so forth, you can also install a dependency from there. Then you can also install these dependency, share the dependencies with the others. What this means, it means that once a dependency is installed, it's actually created, it's actually added to this to a founded the common file, as this, there is a new tag called dependencies, and then the dependencies added automatically like this. For those who work with Rust, for example, it follows very closely the Rust naming and the Rust way of defining the dependency. We can see here as well, if like for example in the cargo, as you can see, has kind of the same structure as soldier. That's why I wanted to keep this as close as possible to Rust implementation. So once you install a dependency, this is added in the in your YAML file, and this is a very strong and powerful option. Why? Because I can just take this founded YAML and share it with anyone, and the only thing that they can do afterwards is just press soldier install, and that's it. So let me open a terminal. You can do this. I can just write something like soldier install, and what this does, like this. What this does is basically retrieving this dependency from the central repo and adding it to the to your dependency folder. I'm gonna go very closely to through how exactly I did this. For those who are familiar with Rust, this is like a code, a Rust code for someone who did not develop in Rust for a long time. So it's kind of like a bit of let's say a newbie Rust code, but I try to improve myself all the time. And it's basically a simple, at core, it's a pretty simple library that I imported into Foundry or as a standalone CLI, and that accepts some commands, as you can see here. And then we go to the commands folder so we can see exactly what commands we can implement. So we can write. So we have an install command, then update, login, push, and a dry run. It's pretty descriptive. It's pretty descriptive on how they work. As you can see here, there are various ways of installing a dependency, and just yesterday I managed to release the Git, let's say the Git feature, which was a quite an important one as people were kept requesting it. So you can install a dependency from the remote repository, and as I said, the remote repository is kind of like what npm.js or Crates.io is doing. But you can also choose to install the dependency from the Git repository. Like you have a Git repository and you actually want to test out or that dependency is not present on the remote repository, you can actually run this command like this, and you can install the dependency from that Git. We do not encourage you to actually use Git. Why? Because we'll be deploying more functionality to the central repository in the future. Something like I don't know, static analysis and more tooling around how to safely and securely store these dependencies while just storing it in a and using Git is not quite the desired. I mean, from my point of view, Solidity is used as a tool to guard like millions of dollars, and we cannot rely on a Git to actually define and let us use these dependencies, because Git was not created actually for this, and we should have a proper dependency manager. That's why I also started to create Soldier. So yeah, Git functionality was added just because it was requested by the community, but we do encourage everyone to use the remote repository and just use the Git as an authority source. So install is one of the most important function in soldier. Then we have a simple update, which is kind of like let's say a clean and install from scratch all the dependencies. We have a version diagram, but I'm not going to just buy this one. This is just like a thing for you to see if soldier was installed correctly. Not the second part of the commands uh, are actually created for someone to push dependencies to the central repository, as you do in npm.js or create.io. You create an account to the remote repository, which is Soldier XYZ, and then you create a project there, and you can push your dependencies to that project and have them available for the community. And this push function, it's pretty simple as well. You just define the dependency. You can, if you want, define a path that the dependency is located in case you actually want. You can also perform a dry run. What this means, a dry run means that it creates a zip file with what it will be pushed to the central repository in case you want to actually inspect before pushing anything to the repository. And they have an additional flag called skip warnings. Why? Because there is a warning that is triggered every time you try to push, let's say, a sensitive file. Because as you know, usually when you push something to a repository, if you are not, let's say, aware of what you push, you can push a .n file or like, I don't know, a config file that should not be pushed. And we implemented this feature where before pushing, it looks through all the files that you are trying to push, and in case a dot file is present there, it will show you a warning saying, hey, you are, it seems that you are trying to push some sensitive files. Are you sure you want to continue? And of course, this is very good when you push it manually, but if you have this in a CI, this functionality will actually break, it will break the pipeline. So we added this extra, let's say, field called skip warnings, which will tell you that, hey, just keep all the warnings and push it no matter what. Of course, this is quite dangerous, but it relies on the user to actually know what they are doing and being safe. Okay, cool. Now let me just go through really quick how I the code I wrote. So every command is basically handled differently. It's not one thing I like about Rust is that it lets you the freedom to implement functionality in a, let's say, in a more wild way. The problem is that this can become a bit dangerous once your code increases in size. At first, I had just a few files here and it was very nicely, but with over time, as you can see, the number of actually files that I started to write become a bit hard to keep track of, and to make them look not as a complete mess. Well, as I'm still working on actually creating these more modular and so on and so forth, but I try to clean it as much as possible. So I'm handling each subcommand in a specific, let's say, branch, and for each dependency, basically, I split because when you try to install a dependency, you install it like this. So you install, let's say, open Zeppelin at 493. Okay, so this is kind of like how you install a dependency. And this is, I think it's what tilde is very important because this is how you define what dependency you want to install and what version, which is pretty important, right? So what I do, I take this thing, as you can see here, I split it, and I'm just going through it. And after I split this, I do various checks. For example, we check if a remote URL, which means that you want to install from a specific URL or Git. That's why we check that this remote URL, if it's actually an URL or if it's a Git URL. Because if it's a Git URL, then we have to fall to the Git way of installing, which is which I'll discuss a bit in the upcoming minutes. So we see we choose the path that we want to go through. Again, remote URL or not. And if it's not, if the remote URL is not present, it means that we default the remote repository to actually retrieve the URL from for us. And we had a dependency name and version, and we just pull the URL from the remote dependency, and just after that we do a bit more stuff here, retrieving the commit and so on and so forth. In case it's the way to do it. I'm going to details about this in a bit because it's quite interesting. And we do the following steps. Every install applies the same steps. First step is creating a lock and doing a lock check. What this means? Every install has a lock file, exactly like you have a cargo lock file. Probably you are familiar with what a log file means. Every dependency manager has a log file, which is basically a file that specifies exactly what dependencies are installed, the checksum from where exactly it was installed, and so on and so forth. Soldier has its own log file. So we check for the log file, and in case the dependency is already present in the log file, we just exit early because there is no need to install a dependency that was already installed. If that's pretty important. If it's not present in the log file, then we just default to download the dependency. Let's go here and download the dependency. So download the dependency is pretty, let's say, straightforward what it does. Again, it checks again the tunnel to make sure if it's HTTP or Git, because we have two ways of handling dependencies as explained. I have the old remote remote repository way, which is preferred. But in case you actually select the Git, you want to install a dependency from Git, we have to go through via the gateway. The download via HTTP, it's quite simple. Let me go back a second. So it's downloading the dependency from the URL, and it's saving it into a zip file. Right. This is kind of like the raw code that does that. We get every chunk, we save it into a file. This is kind of like the way of Rust is dealing with downloading files to a specific local path. And after we flush everything, we return OK, which means that everything was downloaded as expected. So the dependency at this point is actually downloaded locally onto your machine as a zip file. And now, of course, the next step is to unzip it. We are gonna follow the tunnel of HTTP, and then we are gonna go via the Git tunnel. So we downloaded everything via HTTP. Now we write it into the log file because it's very important to have it written into the log file to make sure that everything gets saved. One important thing here on writing log, probably you noticed it already, but I'm gonna say it again. Once we download the zip file, we perform, let me see where it was. The, the digest here. So once we download it, we also perform a digest on the zip file, and we save the hash that it will be present afterwards in the log file. So something like this. The checksum will be present here, and what's that? Basically, that is just an integrity check. If one is like very, let's say, paranoid about what it's installing, you can create an integrity check integration with the actual zip and making sure that no man in the middle attack happened, and the checksum of that zip corresponds to what exactly was downloaded. This is usually in very high sensitive situations, and of course it is a sensitive, let's say, language because it guards billions of dollars. And I added this as an extra feature that should be actually checked all the time in the pipeline, making sure that what exactly was installed is not something that it should not be there. Okay, and after this is, as I said, this is also retrieved, the hash is retrieved. We go to the write log, which basically writes into the log file, and after this we can say that the dependency was, let's say, installed, was downloaded to locally. Now, we have the unzip dependency because we cannot use a dependency that it's, of course, in a zip file. We have to unzip it, actually create it as a normal dependency, and we perform an unzip on that dependency. The unzip is pretty straightforward as well. Let me go to it. Awesome. So unzip just uses zip extract. We extract it to the target, which is basically the dependency without the zip extension, and then saves it into dependency folder, into the dependency folder. And after that, you have everything working, let's say, as expected. I'm going to talk about cleanup and so on and so forth in a second. But after unzip dependency, it's performed, we go to actually define the config file. This is pretty a pretty important function as well. What this does is basically pretty simple. So the defined config file is defining what file we are using for saving the dependency. So we talked at the beginning about Foundry Table and how we set the dependency, but if you don't use it via Foundry and use soldeer as a standalone CLI, we also have soldeer Table. Soldeer Table is exactly, it mimics as much as possible the Foundry Table, and you will use this as a config file. So here we will have all the dependencies defined exactly as let's say as you save it in Foundry and so on and so forth. So you have all of this defined in the soldier Talmud if you don't use the Foundry, let's say, way of doing things. That's why this defined config file is here. It's very important to know, I probably already noticed, but it's very important to know that soldier was created to work, especially in Foundry, but not necessarily only with Foundry. It's important also because while I think I'm thinking that the integration in Foundry is very important, there may be teams or like, I don't know, projects that maybe they don't use Foundry, and I didn't want I I didn't want that to be a problem. That's why defaulting to using Soldier as a standalone CLI was pretty important for me. Now, once we define the config file, we add it to the config file. It's very important to add it to the config file because we want it to be shareable. So that means if I want in the future to say that, okay, my project uses the following dependencies, I can just share my config file, which can be found in Soldier, and then one can just perform a Soldier, or just something like this, Soldier install or Soldier update, and that's it. All the dependencies will be installed and added to your part. So after we added the config, we do a health check on all the dependencies. This is done. This was done more like a extra step, an extra precaution for me. What this does is basically um, checking that every dependency was actually installed as expected, and it's present there, and so on and so forth. After the health check is performed, we know for sure that dependency was installed correctly and we can move on. So again, this was kind of like the paranoid side of me said, okay, we need an extra health check on the dependency just to make sure that everything was installed as expected. And after that, we do a cleanup. The cleanup job is pretty simple. It's present in this janitor as file. I call it the janitor because I thought that it's his job to make sure that dependency was installed as expected. And the cleanup, what it does, it gets rid of the zip file, which is the initial file, and that's it. That's the only job of the janitor. After the cleanup is performed, the third, let's say, and the final step, it's actually the remappings. The remappings is a feature that I won't talk a lot about because it's still very, if you can say, very raw. What it does is just adding it in a remapping txt, the dependency, so you can use it directly without configuring anything. It's still, if I can call it, it's still a bit buggy in terms of, it still has, for example, it never deletes the if you remove a dependency, it never deletes it from your remappings. It always adding, so it's still a bit buggy, but this is the last feature that I want to take care and tackle next. So making sure that it works as expected. Okay. But I think that was all from from HTTP tunnel. Now let me discuss a bit about the Git tunnel. So when you install a dependency, as I said, you can use the HTTP, which is the remote repository way. And for that, you just do something, as I said, so if you install all ones, put in, let's say, 493. This is the default way of using Soldier. But if you want, you can also use a Git. And for that, you just need to do something like Git at github.com. I think this is something like, okay, let's see Solnik. This is the other way. What it does is basically, at this point, you tell to Soldier that the dependency is not present on the remote repository and is actually present on the Git, on a Git repository. And basically it defaults to this tunnel Git, which calls this very fancy method called download via Git, which was quite a pain actually to develop it. Because I wanted to use the usually I did it in a different way, but after with some, let's say, consultation with the Foundry team, they said that it's better to just use a CLI. And now I'm just using the CLI to actually install a dependency. So what it does, it performs a clone, and then it performs um, ref parse to get the actual last commit of that, let's say, repository, because this will be saved as a hash in the log file. Remember, the log file is kind of like this. It saves the dependencies, and it saves also on the checksum the digest. But because that's we are talking about the Git file here, we will be saving the Git file instead of saving the digest in the log file. So that's why I'm getting here the last commit, the call, let's say, last revision. Now, when you are using downloading via Git, there is another possibility, another option here. For example, you want to use a dependency on a Git repository, but at a specific Git hash, at a specific commit hash. How that will be performed? It's pretty simple. You will do it like this, or you are installed. Let's say Alpine, Zeppelin, whatever, and it's present at Git that okay, let's say it's present here because that's what it is auto completed. But then you just specify the minus -5, which is a revision, and specify the revision. Oh, apparently CodeGPT is saying this is the revision. So if we call soldier like this, then what this does is basically it's performing the same steps, but here, as you can see, it's looking for this hash. If this hash was not empty, and it was, and the first step was success, then we basically do a checkout inside that dependency directory to the specific commit hash to make sure that we use the right to make sure that we use the right files at the specific commit hash. After this is done, of course, that hash will be also present in the log file. And like that's all on the install side of things. Let me talk a bit now about updates. But yes, sorry, go ahead.
So this was a very cool walkthrough, Mario. One question I have is, on a high level, how do I add new libraries to this?
Yeah, this is exactly the push functionality. So you go into Soldier XYZ, create an account, create a project, then you just simply go to your let's say let me open it. Let's say I want to push this, okay? Like I'm in the Soldier, whatever dependency I want to push it. What I do,
Yeah.
I do two simple steps. I make sure that I have a git ignore, because you may not want to publish everything. If you don't have a git ignore, you can create also a soldier ignore, which is a specific file that mimics git ignore. Another thing that I worked a lot to make it as close as possible to git. And let's say I create a git ignore. I store it. This is the same as git ignore, and now I just do this soldier push, let's say, my project and version 1.0, right? And if I run this command, it will basically package everything from this from the directory I'm in and publish it to the remote repository under my project, which is the project that I created, and under revision 1.0. Very important to notice here is that exactly to keep the integrity, you are not able to delete revisions. After you create a project and create a revision, the only thing that you can do is to edit the project description. It's very important because in the past there was like a big discussion and a big I think Elian is kind of like knows this. Yeah, on npm.js there was like a big let's say, no, it was not an exploit. It was actually a problem with one of the open source library that was used in, I think, in React. It was pretty common, and the basically the contributor at some point got mad on something, and he deleted that dependency from the npm.js. And once that happened, all the project's pipelines failed because that dependency was not was not present anymore, and the pipelines were failing. That's why from that point onwards, npm.js said that you are not able to delete your projects or revisions anymore. So I kind of like mimicked that into soldier as well. You are once you push a revision, you are not able to delete or neither the project or the revision, because it's pretty important. We don't want things to get lost, right? And to actually DOS a project. So that's it. That's all you do to push a project.
Nice. That's really cool. Which projects are installable right now? Like OpenZeppelin, the big stuff are already installable, right?
Yeah. We have all of like the big projects. Open Zeppelin, Summit, Solari. We have a lot of account abstraction that I added recently. We have 4 the every so anyone can actually go to soldier XYZ and check them out. You don't need an account to pull stuff from the remote repository, but you need an account to push projects to the central repository. For now, we do not have private repositories. It's something that I want to work on, but I did not see the need yet from the community to use it. So it's something that I want to get, but not yet.
Yeah.
Yeah.
Nice.
The project is fully open source. It will be always open source. Well, I'm not gonna move it. There may be, for now it's open source, there may be some additional costs we will see. I'm not saying 100%, but I'm hosting this all on my like on my own money. Like no, I don't have a company behind it, or I don't ask people for money for anything on Soldier. So for now, everything is free, but there may be some additional costs in the future if we introduce some novel things around pipelining and so on and so forth. For example, at some point, I want to add some static analysis and all sorts of like security related functionality around dependencies. So you know for sure, for example, if I have a version of Soldier, I want to know if that version was audited or not. It's pretty important. I think it's something that is pretty important, right? I remember back in the days when, for example, closed immutables was, let's say, created, and I had a review, and I kept searching what version was audited and if it was ever audited by anyone. That's pretty, it's a pretty important information from someone who uses a dependency. And that's something that it's planned to be added on the central repository, like a functionality. And I have like lots of ideas around it. Like I said, static analysis, maybe, I don't know, automated fuzzing and so on. And for that, it can be actually added around it. And all of those, of course, will increase the cost and my cost to host this and so on and so forth. So there may be additional things that you have to pay. Nothing is decided right now. For now, everything is free. But if something will let's say get into that, I'll announce, of course, from with a lot of time beforehand taking that decision. But for now, the base functionality and everything for you to use and to let's say to to integrate it into a project will be free. There is no need to basically pay for it.
Nice. That's fantastic, man. No,
And
listen, I think
yeah, but
in the community, we really needed this. Like like I mean it. Like I love Foundry, but I think the biggest pain point with Foundry was like managing dependencies and versions and stuff. So it's fantastic to have this. I must be honest, I still haven't used it myself for Diode or any project that I have, but anything that I write from scratch from definitely use soldeer to manage packages. So yeah, great work, man.
thank you. That's why I also created it, because I saw the need. I first try to resolve one of my problems, which is this. Thinking about, I'm going through lots and lots of code bases, and all of them have different structures and so on and so forth. And every time when I try to see, okay, what version this code base is using for this specific dependency was actually a pain. And yeah, that's why I created Soldier, because I wanted to solve this.
No, fantastic. When was it merged into Foundry? Like a couple of weeks ago, right?
Yeah, I think that it has been already a month or something. Was official.
Mm,
Well, the initial PR was created a long time ago, but we had a lot of discussions. I had a lot of discussions with the founder team, which were supportive, and I want to thank them. And they gave me a lot of ideas and so on and so forth. The main thing around it was that we don't want to merge, and I completely agree with them. We don't want to merge something just to create other problems. We want to merge something that we envision. It will basically will be the path to defining what exactly a dependency means in Solidity, and in general in smart contract development. What exactly a dependency means and how it's defined, and what metadata for that dependency you want to have, and so on and so forth. So after we discussed some initial plans, we decided, okay, let's go with it. So since that is pretty stable at this point, let's go with it, let's merge it, and now we iterate over this with the feedback from the community.
nice. Maybe talk a bit more about the process of merging this into Foundry. Like just that was something interesting to me.
Oh yeah, uh, well, in order to merge it into Foundry, first I had to create it as a library, because I had it as standalone CLI, but you had to have it as a library, because this is basically an additional library into Foundry.
Mm,
After you have that, uh, you create a PR. Of course, you get an issue, get a PR, and then the Foundry team takes, let's say, the ropes and starts to review what exactly it's implemented. They are very thorough, and I completely agree with them on what exactly it's merged. Like, for example, one of the issues I had was that I kept importing lots and lots of libraries that are useless, or like they are, let's say, not so safe in terms of
mm,
like not so safe in terms of they are not so known or stuff like that. Uh,
mm,
then they said, okay, we need to get rid of this. For example, on the Git feature, I used an old library called the Git 2, which imported 3 additional C libraries. And when I wanted to actually add it to the Foundry, the Foundry team told me that, yeah, this adds 3 new C libraries, which is something that we don't want at this point. We also got rid of this additional functionality, and we just went straight to the CLI. So that's why I had to redo it over the weekend. It it created me a lot of pain, but well, I had to redo the whole functionality, not using that specific library and just using the raw CLI, Git CLI. So yeah, that's something that I care a lot regarding the what exactly is added and what dependencies needed to be added. And after I stripped everything that was not necessary out, the next suggestion from them was to create some integration tests, very important integration tests, making sure that if you want to update this new feature and so on and so forth, it will work as expected. So I worked on that as well. And after I had the integration tests and the team was pretty open uh, to review everything, they say, okay, it's time to merge it. So kind of like that, that's usually the process. You come up with a initial solution, they review, they give you some additional context on what, because they are Foundry is getting more and more complex and with more and more functionality. So we have to be very careful what we add on top of existing features. And after that review, the team will be give you feedback how to implement and so on and so forth. And then you get into the, let's say, into the main Foundry, let's say, release.
Nice. Nice. Listen, Mario, great job, man. You really built something very useful to all of us. So, yeah, this is awesome, man. Uh, yeah, thanks for doing the walkthrough. So really interesting. Uh, I'm gonna put the repository, and soldeer has a website now. I didn't even know that.
Yeah.
Soldeer has a website now, which I'm gonna put in the description down below. If you guys wanna work on this, all open source on GitHub, look at some issues that are open. Any good first issues to look at, Mario?
Oh, there are lots. I usually tag them as a good first issue. So whoever checks out the GitHub of Soldier can also see all of the good first issues. I mean, we have some nice contributions so far, so I encourage everyone to contribute more. I'm doing this a lot, so I'm not. I don't mind, but of course, more people working towards this, it's always a help.
Perfect. So if you guys wanna work on this, take a look at the GitHub, reach out to Mario if you have any questions. Mario, thank you very much for doing this, man.
Awesome, no, thank you for having me, and yeah, let's hope Soldier will be a good solution for everyone.
For sure, man, for sure. Thank guys for tuning in, and I will see you in the next one. Take care. Bye bye.
Bye bye.